The Retribution Mars rover is an impressive vehicle with a sleek and futuristic design inspired by science fiction movies like Interstellar and Star Wars. Equipped with state-of-the-art technology, it has the capabilities to conquer the challenging terrains of Mars and conduct scientific exploration. Let's explore its key features and functionalities. One of the standout features of the Retribution rover is its high profile, providing a significant advantage when navigating rough terrains. With a clearance of around 3 feet, it easily overcomes obstacles that could hinder other rovers. The primary arm of the Retribution rover serves as the main manipulator for sample retrieval, analysis, instrument deployment, and environmental interaction. It incorporates an infrared-capable camera, enabling detailed analysis and close-up zooming, similar to a microscope. The arm's main base assembly uses 15 mm bolts with a tolerance range of plus or minus 0.02 mm, ensuring a secure and stable connection with proper alignment and strength. For other joints, 5 mm bolts with a tolerance range of plus or minus 0.02 mm are employed, maintaining functionality while allowing for easy assembly and disassembly. A clearance fit between mating parts enables smooth rotation and articulation of the joint. To withstand the harsh Martian environment, the Retribution rover features a chassis constructed from lightweight yet durable materials like aluminum and titanium. This construction offers strength and rigidity while keeping the overall weight low. Additionally, a protective shell shields the sensitive electronic systems from extreme temperatures, radiation, and dust storms. Power is a crucial aspect of the Retribution rover, which relies on solar panels and a radioisotope power system. The radioisotope power system generates electricity from plutonium's radioactive decay, providing a lifespan on Mars' surface of at least a full Martian year or more. This power source enhances mobility, operational flexibility, and science payload capability, enabling exploration across a wider range of latitudes and altitudes. Lightweight and efficient semiconductor solar panels capture sunlight, converting it into electrical energy for storage and later use. Setting it apart from previous rovers, the Retribution rover features a unique wheel steering system. While the front wheels steer conventionally, the 2 back wheels also steer, enabling a smaller turning radius. This configuration enhances maneuverability through tight spaces and aids in overcoming challenging obstacles. Built to withstand the rugged Martian terrain, the wheels and suspension systems utilize durable materials like aluminum or titanium, ensuring optimal traction and shock absorption. The Retribution rover employs a specialized center lock wheel fastening system. Instead of traditional nuts, a single large nut secures the wheels directly onto a central hub. This nut is tightened using a pneumatic or hydraulic wrench, ensuring a secure and swift attachment. The wheel nuts have an interference fit with a tolerance range of approximately plus or minus 0.02 mm, guaranteeing a precise and reliable connection capable of withstanding Martian conditions and vibrations. Scientific exploration is a core focus of the Retribution rover, equipped with a range of scientific instruments including spectrometers, cameras, and sensors. These instruments analyze the Martian atmosphere, rocks, soil, and other features, gathering valuable data about the planet's geology, climate, and potential for supporting life. For comprehensive environmental awareness, the rover boasts advanced camera systems. The main camera provides a 360-degree view, aiding in thorough reconnaissance, with a zoom feature for long-distance analysis. Strategically placed lights on each side, front, and back enhance visibility in various lighting conditions. The camera is securely fastened using 10 mm bolts with a clearance fit for rotation, along with a 10 mm nut with an interference fit for stability. Effective communication is crucial for the Retribution rover's Mars mission. It utilizes antennas and communication systems to transmit data back to Earth. By establishing a direct line with Mars-orbiting satellites, the rover relays findings and status to mission control. The radar is attached using 20 mm bolts with a clearance fit, allowing rotation, secured by a 20 mm nut with an interference fit for stability. The Retribution rover's advanced autonomy ensures efficiency and adaptability on Mars. Powered by robust onboard computers and sophisticated software, it makes intelligent decisions, navigates diverse terrain, and responds to unexpected situations. A key feature is its ability to process sensor data, providing vital information on terrain, atmosphere, and hazards. By integrating this data into its algorithms, the rover autonomously selects optimal paths, avoids obstacles, and adjusts operations in real time. The Retribution rover operates autonomously, relying on powerful onboard computers and sophisticated software systems for intelligent decision-making, terrain navigation, and response to unforeseen circumstances. Its sensors provide crucial data about the surroundings, enabling the rover to choose optimal paths, avoid obstacles, and adapt operations in real time. Machine learning algorithms enhance its autonomy, allowing it to optimize energy consumption and prioritize scientific targets. Communication with mission control facilitates exchange of plans, updates, and instructions. Advanced protocols and data compression techniques ensure seamless communication, minimizing delays despite the significant distance between Mars and Earth. Thank you for being part of the Retribution Initiative, and may our shared passion for discovery guide us on this extraordinary voyage of knowledge and exploration. May you have a safe and inspiring journey ahead.